Assalamu alaikum. I am Jahangir Alam, lecturer in physics at Milestone College. I welcome you all in my online class. First of all, thanks to Almighty that He has given me the ability to take this class, and still I am carrying on my regular activities. Dear student, I also hope all of you are well with your family by the mercy of Almighty. Right? Dear student, in our today's class, we are going to discuss the very basic item from the 9th chapter of physics first paper. Okay? That is the chapter of wave. And I hope you will be benefited from this class. Dear student, so let's start our class. Right. Dear student, here I believe that all of you have the basic idea about wave, because in earlier classes you have read about the wave and you got the definition of wave. Actually, the wave is a periodic disturbance or periodic vibration of the particle of elastic medium which can transfer energy or information from one place to another place without changing position of the particle. That is, the particle of the elastic medium will not change its position, but it transfer energy or information from one place to another place. Okay? So, dear student, now we can give the definition of wave. Right, dear student, so we can give the definition of wave as the periodic vibration of the particles of an elastic medium which transfer energy from one place to another place of the medium without need change of position of the particle is called wave. Right? It's a very important definition. Okay? Dear student, I hope you got it. Dear student, on the basis of the dependence on medium to propagate, mainly waves can be divided into two types, and they are mechanical wave and another is electromagnetic wave. Right? The basic difference of these two waves are mechanical wave medium require medium to propagate. Without any medium, it cannot propagate. On the other hand, it does not require any medium. That is, mechanical medium or any medium is not necessary to propagate of electromagnetic wave. Right? So, for example, mechanical waves are water wave, spring wave, sound wave. These are the mechanical wave, because this type of wave medium is necessary. Without medium, this type of wave cannot possible. But light, X-ray, gamma ray, these are electromagnetic wave, because without any medium we can get light from the sun. Okay? So, light are coming from the sun to our earth without any medium. Similarly, gamma ray, X-ray, these are also electromagnetic wave. This does not require any medium to propagate. Okay? So, dear student, I hope you got it. Now, we will see the classification of simple harmonic wave or mechanical wave. That is, on the dependence of the direction of vibration of the particle of the wave transmitting medium to the direction of propagation of wave. The wave can be divided into two types. One is transverse wave and another is longitudinal wave. Right? If the particle of the wave transmitting particle vibrate normally to the propagation of wave, then this type of wave are known as transverse wave. Okay? On the other hand, if the particle of the wave transmitting particle vibrate parallel to the direction of propagation of wave, then this type of wave are known as longitudinal wave. Right? Dear student, these two waves are very important. So, now we are going to see the definition of transverse wave and longitudinal wave. Okay. Dear student, so definition of transverse wave is given here. When the particles of the wave transmitting medium vibrate about their mean positions perpendicular to the direction of propagation of wave, then the wave is called transverse wave. As per example, water wave, string wave are the transverse wave. Direction, you can observe the figure. Suppose this is a wave shown in the figure. Here the wave is propagating from this direction to this direction. So this is the direction of wave. But in this figure, it shows that the particles are vibrating from their mean position. Here the green line indicates the mean position. The particles are vibrating from mean position in the upward direction perpendicular to the green line, and in the next half they are vibrating from the mean position to the lower direction. So here the direction of the propagation of wave is indicated by this line. Direction of propagation of wave is direction in the line. The particles are vibrating in this plane. Here the angle between the propagation of wave and the direction of vibration of the particle is 90 degree, right? So we can say that here particle of the medium are vibrating perpendicular to the direction of propagation of wave. So this type of wave are known as transverse wave. Okay, dear student, now we will see the another definition, that is definition of longitudinal wave. When the particles of the wave transmitting medium vibrate about their mean positions parallel to the direction of propagation of wave, then the wave is called longitudinal wave. Okay, as for example, sound wave, spring wave, these are the example of longitudinal wave. In the figure you can show that, you can see that, sound wave can propagate, that is sound energy can transfer from one place to another place through the rarefaction and compression of air layers. In the figure we show a compression of air layers and there is a expansion or rarefaction of air layers, right? When we apply sound energy to the air layer, there is a compression of air layer, and on the both side of the compression there is a rarefaction of air. Again on the both side of a rarefaction there is a compression of air. So in this way sound energy can transfer from one place to another place through the compression and rarefaction of the air columns. So in this case the direction of wave is like this, wave is transmitting in this way. So direction of wave is shown here, and the direction of the motion of the particle is in the both direction, that is in this direction and in this direction. So here the direction of the motion of the particle is parallel to the direction of the propagation of wave, right? So these waves are known as longitudinal wave. Dear student, for the better concept about transverse wave and longitudinal wave, you need to see the characteristics of these two types of wave from your textbook. Okay, so reading these characteristics of the longitudinal wave and transverse wave, you will be benefited and you will get many question or MCQ type question from these characteristics of longitudinal wave and transverse wave, right? I hope you got it. Now we will see some important terms or definitions relating to wave, and this term or definition will help us to realize the whole chapter. Okay, dear student, so let us see the definition. Dear student, first we will see complete oscillation, right? So complete oscillation says that when an oscillating particle or body starting from a point come back to the same point from the same direction, then it is called complete oscillation. Suppose a particle is moving in a circular path centering a point. If the body complete one rotation, that is the particle is come back to the same point from the same direction, then it will be one complete oscillation, which can be represented in the figure by if the wave of the particle represent from the point A, then it will complete its oscillation after coming at E, that is after reaching E it will complete its one oscillation, or the point at A and E it will show the same phase, right? And from E it will start the new cycle. So this is the complete oscillation. Now we will see another important definition, that is wavelength. It's a very important definition. Distance traveled by a wave during one complete oscillation of a wave transmitting particle is called wavelength. In the figure, AE, BF or CG indicates the wavelength. That is shown, when a particle execute one complete oscillation, that is represented by this portion of the wave, right? So that is when it complete one oscillation or one rotation, it will be represented in the figure from A to E. So the distance travel by this wave in during one complete oscillation of a particle will be A to E, because within this distance it will complete one oscillation. So this is the wavelength. So wavelength is denoted by lambda, or the particle starting from B, when it reaches to F, it will be one complete oscillation. So it will be also denoted by lambda, right? So wavelength is denoted by lambda. So BF or A to E, these are wavelength, right? Okay, tell student, now we see a time period, that is time required to execute one complete oscillation by the wave transmitting particle is called time period. It is denoted by capital T. Dear student, when a wave will propagate from A to E, in the meantime it will execute one complete oscillation. So the time required to traverse from A to E or execute one complete oscillation is called time period. Okay, I hope you got it. It's a very important definition. Now we will see the frequency, right? So number of complete oscillation executed by the wave transmitting particle in 1 second is called frequency. That is, number of complete oscillation executed by the wave transmitting particle in 1 second is called frequency. Frequency is denoted by F or N, and its unit is hertz or per cycle. Okay, dear student, now we will see another term, that is amplitude. The maximum displacement in either direction of a vibrating particle from its mean position is called amplitude. Dear student, in the figure, you know, this line indicates the equilibrium or mean position of the wave transmitting particle. The particle are vibrating in either direction. There some particle are vibrating in the upward direction and some are particle in the vibrating in the downward direction. So in the upward direction this is the maximum displacement, in the downward direction this is the maximum displacement. So this maximum displacement is called amplitude, right? I hope you got it. Okay, dear student, now we will see a very important definition. Okay, the term is phase, right? Actually the term phase expresses the overall condition of a wave transmitting particle at any instant. Okay, so definition can be expressed as the overall condition of motion of a wave transmitting particle at any instant is called phase. Dear student, here overall condition of motion means that is the position of the particle, the velocity of the particle, the acceleration of the particle, all the characteristics commonly known as phase of the particle, right? I hope you got it. Dear student, now we will see another very important term, and the important term is wavefront. Okay, so the definition of wavefront is the continuous locus of the vibrating particles having the same phase is called wavefront. In our earlier definition we have already learned what is phase. So here the particles or the continuous locus of the vibrating particle having the same phase is called wavefront, right? Dear student, in the figure if we consider, suppose this midpoint indicates the source of a wave, right? And the particles of the wave transmitting particle on the green line are equidistant from the source. Since the particle are equidistant from the source, so they are on the same phase. That is, the particle on the green line have the same phase. So this is the locus of the particle having same phase. This is a wavefront. On the same way, the particle on the blue line are equidistant from the source. So all the particle on the green line having the same phase. So this is also an wavefront, right? So in the way we can show that the green line, blue line, green line, blue line, all are the wavefront, all are the different wavefront, right? Dear student, I hope you got it. Dear student, now we will see another important definition, wave velocity. You know what velocity is? Distance traveled by a body in unit time is called velocity. So wave velocity means the distance traveled by a wave in unit time is called wave velocity. It's a very easy and basic definition. Okay, dear student, Now we will see another important definition, that is intensity of wave, right? The definition says that the amount of energy transferred per second through unit area perpendicular to the propagation of wave is called intensity of wave. If we observe this figure, suppose a wave is transmitting in this direction, the direction of wave is shown here. If we consider a plane perpendicular to the direction of propagation of wave, then the amount of energy which is passes through the unit area in 1 second, right, is called intensity of the wave. The intensity of the wave is denoted by I, capital I, and the expression for the intensity of wave is 2 pi square rho n square or f square v square a square. Dear student, here 2 pi are the constant quantity, rho is the density of the medium through which wave is propagating, n, here n is the frequency, v is the velocity of the wave, and a is the amplitude of the wave. Dear student, for a specific source and a specific medium, for the specific source the frequency will be constant and a specific medium velocity will be constant. For a specific source and a specific medium, all the quantities will be constant, right? So in that case we can write that I proportional to a square, that is the intensity of sound is directly proportional to the square of the amplitude of the wave. Okay, this is a very important expression for your MCQ and mathematical problem. Now we will see a simple and easy relation, that is the relation between time period and frequency. Dear student, in our previous discussion you know what time period. The required time to execute one complete oscillation by a particle executing simple harmonic motion or wave transmitting particle is called time period. Time period is denoted by time period is denoted by capital T, right? And the frequency, that is the number of complete oscillation or vibration executed by a wave transmitting particle, is called frequency, right? So frequency is denoted by small f. And you know, we have already learned in our previous classes the relation between time period and frequency is T is equal to 1 by f or f is equal to 1 by T, right? This is the relation between time period and frequency. Okay, dear student. Now we are going to see another important relation, that is the relation between wave velocity. Okay, wave velocity, frequency and wavelength. You know what wave velocity is? The distance traveled by a wave in unit time is called wave velocity, right? Wave velocity is denoted by v, frequency is denoted by f, and wavelength is denoted by lambda. You know, you have learned the relation between v, f and lambda from our previous class. The relation between this quantity are v is equal to f lambda, right? So this is the relation between v, f and lambda. That is student. Now we will see some mathematical problem using this mathematical expression, right? Students, here is our first mathematical problem. In the problem they said that a sound wave travels a distance of 1020 meter in 3 seconds, right? This is a distance 1020 meter in 3 seconds. If the wavelength of the wave is 50 centimeter, then find its time period, right? So according to the question, they said that the wave travel 1020 meter in 3 seconds. From this information we can calculate the wave velocity, right? Here wave velocity v is equal to, since its distance 1020 meter in 3 seconds, so distance in 1 second will be the velocity. So 1020 meter divided by 3 second. So it will be 340 meter per second. This is the wave velocity, and the wavelength lambda is equal to 50 centimeter, that is 0.5 meter. So using this expression, dear student, first we need to calculate the frequency of the wave, then we will find the time period. We know V is equal to F lambda, or F is equal to V by lambda, right? Here the value of V is 340 meter per second and lambda is 0.5. So after the calculation you will get 680 hertz, right? Again, you know, time period T is equal to 1 by F, okay? So 1 by 680, and after the calculation you will get 1.47 into 10 to the power minus 3. So unit of time period will be second, right? So this is the time period of the wave, okay? My dear students, here is our second mathematical problem. In the problem they said that a sound wave travels 300 meter during 50 oscillations, right? The distance 300 meter traveled during 50 oscillations. If the frequency of the wave is 150 hertz, then what is the velocity of the wave? So from the first line of the question we found that in 50 oscillation it travels 300 meter, right? So from this information we can calculate the distance during one oscillation, and which will the wavelength of the wave, right? You know, the distance travel during one complete oscillation is called wavelength, but there they said that distance in 50 oscillation. So if we divide 300 by 50, then you will get distance during one oscillation, and which is wavelength of the wave. Here wavelength lambda is equal to 300 meter divided by 50, that is 6 meter, okay? Frequency F is equal to 150 hertz. So velocity V is equal to what? We know V is equal to F lambda. Here F is equal to 150 hertz multiplied by 6 meter. So after the calculation you will get 900 meter per second. Dear student, this is the velocity of the wave, okay? Dear student, here is our another mathematical problem. This is a very important question. In the question they said that in a medium the frequencies of two sources are 480 hertz and 320 hertz, that is the frequencies of two sources, and the differences of their wavelength is 2 meter, right? So what is the velocity of the wave in that medium? Dear student, here the frequencies of the two medium, frequency of first source F1 is equal to 480 hertz, right? So frequency of second source F2 is equal to 320 hertz, right? and they said that difference of their wavelength. Dear student, you know which wavelength is greater and which one is smaller. They only said that the difference of their wavelength is 20 meter, and if the respective wavelengths are lambda 1 and lambda 2, so using this symbol we can indicate the difference of lambda 1 and lambda 2 is equal to 2 meter. So we need to determine the velocity v is equal to what? Dear student, here you need to remind it that in today's class we have already earlier, if the medium is same, whatever the sources, the speed of sound will be same. That is, in a specific medium, the sound produces by the all sources will be same, right? So sound produced by the first source whose frequency is 480 and sound produced by the second source whose frequency is 320 will be same for the same medium, right? So you know the wave velocity v of a sound is denoted by f into lambda, right? Dear student, if we consider this expression for the first source, that is whose frequency is denoted by f1, so we can write that f1, and if the respective wavelength is lambda 1, then we can write that v is equal to f1 lambda 1. Similarly, we can write that v is equal to f2 lambda 2, because the velocity for the both sources will be same. So we can write equal to f2 lambda 2, right? So from this part of the relation we can write, or f1 by f2 is equal to lambda 2 by lambda 1. Dear student, from the given value of this question, you know, in the f1 480 and f2 is 320, so obviously f1 is greater than f2. So in this ratio, f1, that is numerator of the fraction, is greater than the denominator of this fraction. So since these two fractions are equal, so in that part lambda 2 must be greater than lambda 1, right? Since in this fraction numerator is greater, so in this fraction numerator should be greater, right? So here we can write, since f1 greater than f2, therefore lambda 2 greater than lambda 1, right? Here they said that the difference of their wavelength is 2 meter. Now it is clear to us that lambda 2 is greater than lambda 1, right? So we can write now lambda 2 minus lambda 1 is equal to 2 meter, because they said the difference of their wavelength is 2 meter. Since lambda 2 is greater, so lambda 2 minus lambda 1 is equal to 2 meter. Dear student, now we can write from this expression, if we would like to calculate the value of lambda, so we can write that lambda is equal to v by f. So for the lambda 2 we can write v by f2 for the lambda 2 minus v by f1 is equal to 2. So if we rearrange the expression v, we take v as common, 1 by f2 minus 1 by f1 is equal to 2, or v into f1 multiplied by f2, so you will get f1 minus f2 is equal to 2, or v is equal to 2 multiplied by f1 f2 divided by f1 minus f2. So using this value, so 2 multiplied by f1 means 480, f2 means 320 divided by f1 means 480 minus 320, right? Yes, and after the calculation you will get 1920 meter per second. So speed of the or velocity of the wave in that medium is 1920 meter per second, right, dear students? So I hope you got it, and I hope this class will be helpful for you, dear student. Thank you very much being with me in my class. May Allah bless all of you. Assalamu alaikum.